Good morning, student. Let's start today's class. In today's class, we are going to study about the third type of measuring uh, device, which is COP anemometer, okay, or Robinson anemometer, okay. That the basic principle behind the working of this anemometer is the fact that the resistance to the flowing stream is greater for a concave shaped cover curved surface than for a convex shaped surface. Okay, this anemometer carry across at the top, okay, of a vertical support with 3 or 4 hemispherical cup. The main advantages of this instrument is that it is not necessary to move this equipment in the direction of wind, because also this is the cup anemometer. Okay, here the principle is what you see. There is a stand, okay, and in the there is 3 or 4 cups are there, okay, and in top there is an arrow, or there is an metal plate, okay. This metal plate is for always uh, pointing toward, or the uh, mm, always pointing towards the flow of wind, okay. If the wind flow this direction, the metal place this direction automatically, okay. If flow of wind is this direction, the metal is uh, uh, placed himself in this direction, okay. So the metal plate placed himself, or adjust himself, okay, with the flow or stream of the uh, direction of the stream of the air, okay. And here one on concave spherical semi-spherical, okay, cups are there, and these cups are rotate by the force of wind, okay. This cup rotate by the force of the wind, okay. And we can measure the velocity of the wind by measuring the rotation speed, okay. This is the principle of cup anemometer, okay. Then the basic measurable parameter, that is the frequency of rotation of a cup anemometer, depends initially on the wind linearly on the wind velocity, okay. The following an empirical relationship is valid, okay, for a cup anemometer, okay. That is V equal to VA plus VB into V, okay, where V is this small v, this small v, this small v, v is peripheral velocity of anemometer, okay. Then va is, a is friction coefficient meter per second, and ba is proportionality vector, okay. And small v is wind velocity, this is wind velocity, okay, capital V, and the small v is the peripheral velocity of anemometer, okay. The anemometer is practically generally have a following value of constant, that is va this and va in between that value, okay. Due to the friction in the support, the wind velocity equal to aa or slightly greater than aa cannot be measured accurately, okay. Due to this friction, due to this aa, when the velocity of the wind is slightly greater than aa, then that velocity cannot be measured due to the friction, okay. And 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 one therefore try to minimize the friction by taking softly moving support, lighter curve, or a constant free rotation counter as far as possible. Yeah. If you if you taking this precaution, then you can also uh, measure the wind velocity, which is slightly greater than AA. Okay. With quickly increased wind velocity, such as natural storm, one noticed that inertia in inertia of the equipment, okay, the wind velocity measured by the apparatus corresponds to some previous value of the wind velocity. Okay, the COP anemometer fit more for measurement of those wind where velocity is increasingly rather than the decreasingly. Okay, the indicated wind velocity value on an average are slightly higher than the actual one. Okay, now you see the calibration of anemometer usually done in an wind canal. Okay, in an wind canal, okay, the constant AA and BA are determined irrespective of a particular instrument. To determine the wind velocity, the number the number of rotation in the corresponding time interval in an recorded, and the wind velocity is calculated by the expression this. Okay, velocity is AA plus BA into 2 pi, 2 RA pi NA. Okay, RA here, RA is the radius measured between the axis of rotation and the middle of the curve. That means this radius. Okay, here from this to this radius, this is RA. Okay, from this much to this much. Okay, then Na is rotation frequency. Okay, then now let us discuss about wind direction indicator. Okay, recording recording wind direction is usually accomplished with the help of wind vanes. Okay, the position is mechanically or electrically transferred to either an indicator or a recorder. Okay, wind vane, okay, wind vanes be so should be so installed in such a way that they do not refer any particular direction. Okay, otherwise for weak wind they will show strong direction, okay, wrong direction. Information about the wind direction is given either by distributing the sky into 8 sector or indicating the direction in an angle. Okay, when the maximum accuracy obtained, both these scale are given in the table. Is wind coming from south is given the direction as 180 degree, and the one from east is 90 degree. Okay, that means the wind direction, this is our globe. Okay, and this is 360 degree. Okay, so when in the chart that you see, when north, okay, this is 360 degree. Okay, when northeast, this much 30 or 60. Okay, and when east, this is 90. Okay, when south is 180, and southeast there is 2, 120 and 150. Okay, then uh, west is 2 70, okay, and here is 2, okay, this 2 is 210 and 214. This is southwest, okay. Similarly, northwest. You see here, you see here what happened. This is the globe, okay, and this is the, in previous classes we have decided that the direction of wind, okay, is divided into 8 direction, okay, that is north, east, south and west, okay, and this is northeast, this is southeast, this is southwest and this is northwest, okay. So these 8 type direction are there in for a wind, okay, and this direction is indicated by some angle, which is this north is indicated by 360, sorry, 360 degree, okay, and this is, and you see this north is this 360 degree and east is 90 degree, south is 180 degree, west is 270 degree and north is again 360 degree, okay. Then the center center is 00, okay, and the northeast there are two, okay, given, which is 30 degree and 60 degree, okay, and southeast is 180 120 degree and 150 degree, and southwest is 210 and 240, okay. The northwest is 300 and 330. This degree is indicate the wind direction, okay. That means the wind is flowing, let's say 360 degree north, okay. That's like, okay. That's all for this class. Thank you.